All right, welcome and thanks for joining for section 1.1 optional video of examples. You can tell who's an overachiever already, and we'll see if you continue that way throughout the rest of the year. So in this video, you can see sort of up here in this top right corner, there's just 5 slides. I am sort of going to be jumping around a little bit. So in between slides, if you need to like pause and catch up to where I am, totally fine. Another cool thing with these videos is usually I try and keep them so that you can skip around. So if you feel like you know how to do the problem, you don't want to listen to my voice or watch my explanation, and you just want to pause it and then do the problem yourself, see what my answer is by skipping ahead, you're more than welcome. Just keep in mind you may miss some of my wonderful explanations, but certain topics like this topic, you might be totally fine. So, example of finding slope. The slope between 2 points, 3, 5, and 7, 11, is, remember that what we do here is x1, y1, x2, y2. So I'm going to be doing 11 minus 5 over 7 minus 3. 11 minus 5 is going to be 6. 7 minus 3 is going to be, whoa. Oh, never mind. 11 minus 5 is going to be 6 for some reason. I thought it wasn't. 7 minus 3 is going to be 4. And 6 over 4 is going to give us 3 halves. All right, yeah, simple subtraction sometimes, I'm not very good at it. On your own, or, I'm going to do it right here really quickly anyways, but on your own, if you want to try these again, pause, come back to it. But I'm just going to, keep going. So 6 minus 0 over 1 minus negative 2. When I see this 1 minus negative 2, it's perfectly okay if right away you just put plus. Prevent yourself from making a mistake. So we get 6 over 3, which is 2. Always make sure that you reduce your fractions. There won't be a time this year where I tell you, no, don't reduce that. B, 3, 5, and 6, negative 1. So I'll do negative 1 minus 5. I know, not a ton of space for this. 6 minus 3. Negative 1 minus 5 is negative 6. 6 minus 3 is 3. So this gives us negative 2. Just a little, talking ahead. 2 and negative 2 are opposites. One's positive, one's negative, but they're not reciprocals. So this would not indicate something that's perpendicular, nor would it be parallel. All right, part C, fractions. Just a little talk on fractions. If you're bad with fractions, you need to get some help with fractions or practice fractions because they're going to show up on tests, they're going to show up on quizzes, they're going to be a little bit monstrous, and they're on the non-calculator portion of those things. So you need to learn how to work with them. They're really not as much of a nightmare. They just are visually overwhelming. So here, same process. I'm doing y2, 3/4, minus y1, 1/4, over x2, negative 1/2, minus x1, 1/3. Now in the top, in the numerator, this is a pretty nice fraction because they have the same denominator. So you would just subtract 3 minus 1 is 2 over, you keep that 4, which is 1/2. In the denominator, we have a little bit more work because those don't have a common denominator. So we have negative 1/2, just writing it off to the side, minus 1/3. If I'm getting a common denominator here, the common denominator would be 6. So I'd be multiplying by 2 over 2 and multiplying by 3 over 3 so that I can get that common denominator of 6. This gives me negative 3/6 minus 2/6. And now when I subtract that, I get negative 5/6. So I have 1/2 over negative 5/6. And then it comes down to, okay, when I'm dividing fractions, what I can do is multiply by the reciprocal of the denominator. So what I'm just going to change this into now is 1/2 times negative 6/5, which gives me negative 6/10, which is negative 3/5. I'll totally agree with you. It's a little bit more tedious of a process, but it's easy, tedious stuff. It's not stuff that we should, panic as soon as we see that, oh my goodness, there's fractions and I have to subtract. It's subtraction. It's still just subtraction with a little bit of multiplication. And those are two skills that we know how to do. All right. So moving along, again, you're going to have to go find the slide. I'm also going to go find the slide. What you can see over here is on the right, I do actually have the answers already given. That's not typical, but for here it is. On your own, again, I'm going to do it with you anyways, write the equation of the line with the given slope that passes through each point, or two given points in this case. So I've got a slope of -1 and the point 2,5. What I'm going to do is start this off in point slope form. So I'm going to be doing y minus y1 equals m times x minus x1, and then converting it to slope intercept. So I'd have y minus 5 equals -1 times x minus 2, which gives me y minus 5 equals -1x plus 2. No, you don't really need that -1. You could just put -x and add the 5. So y equals -1x plus 7. All right, slope of 4 and going through the point -3, -2. So we'll have y plus 2, again, because it's minus negative, equals m, which is 4, times x plus 3. This gives me y plus 2 equals 4x plus 12. And subtract to this 2. So I get y equals 4x plus 10. Last, I have 2 points. When I have 2 points, the first thing that I'm going to have to do is find the slope in between them so that I can use point slope form. So if I'm going to find the slope here, I'll do -3 plus 2 over 8 minus 12. That gives me -1 over -4, which is 1/4. So we know what m is. Now, this problem just becomes the same as numbers 1 and 2. And you can pick either one of these points to use. So I'm just going to use this first one, x1, y1. I'll have y plus 2 equals 1/4, our m value that we found, our slope, times x minus 12. You can be strategic a lot of times with what you pick. For instance, in this case, I'm doing 1/4 of some number. So it's helpful to pick something that's divisible by 4. In this case, it didn't matter which one I picked because both of these x's were divisible by 4. And if you picked something that wasn't, you would still get the same answer. So we get y plus 2 equals 1/4 x minus 3. So y equals 1/4 x minus 5. Again, all those answers are up here, so you can already see them. All right, skipping one slide and then going to the next one. Are the lines L1 and L2, which is what we're calling the lines, parallel, perpendicular, or neither? So I'm being asked whether or not we have two lines that are parallel, perpendicular, or if they have neither of those relationships. I determine that by finding the slopes of them. So I'm going to find the slope first of L1. So I'll have 5 plus 1 over 1 plus 2. That gives me 6 over 3, which is 2. Then I'm going to find the slope of the second line. So I'll have -5 minus 3 over 5 minus 1, which is -8 over 4, which is -2. As I said in a previous slide, 2 and -2 are opposite, but they're not reciprocals. For them to be reciprocals, you'd have to be flipping over the fraction. So something like 2 and -1/2. So lines L1 and L2 are neither parallel nor perpendicular. All right, moving along, the next one that we have, writing equations of parallel and perpendicular lines. So if I want to write the equation of something that's parallel or perpendicular to a different line, write the equation of a line that's parallel to 4x minus 2y equals 3. That passes through the point 2, 1. So all that I need from this is the slope, because all we're saying is that it's parallel to that. Well, in order to get the slope of this, I have to solve for y. So I'll subtract the 4x. I get negative 2y equals negative 4x plus 3. And I'll divide by the negative 2. So y equals 2x minus 3 halves. You don't really care what this is because all I needed from this was this 2. So the slope of this line is 2. And I want something that's parallel, which means it's going to have the same slope. So we're going to use point slope form. Y minus y1 equals m, which we just determined was 2 because it was parallel, times x minus 2. Simplify this out, put it in y-intercept form, or slope-intercept form, sorry. So we're going to have y minus 1 equals 2x minus 4. So y equals 2x minus 3. Now we could use that same point and that same equation, but now say, what if I want something that's perpendicular? If I want something that's perpendicular, what I want is an opposite reciprocal slope. So now instead of m being 2, we want m to be negative, and you flip 2 over, so it becomes 1/2. Now, the slope of this equation was still 2. I didn't go back and resolve it. So the slope here is 2. The slope of our new line is going to be negative 1/2. So we'll have y minus 1 equals our new slope, negative 1/2, over x minus 2. Notice that these two equations, because we're using the same point, are almost exactly the same. It's just that our slope changed from 2 to negative 1/2, opposite reciprocal. So we get y minus 1 equals negative 1/2 x plus 1. So y equals negative 1/2 x plus 2. All right, and then our last slide of examples. On your own, write the equation of the line with the given relationship that passes through each point. So we're just doing a little bit more of that same practice. Again, I'm going to do it with you. I know it says on your own. You could do it on your own. I recommend that you do it on your own. And then, just check whether or not it's right. So we want something that's parallel, which means the same slope, to 2x plus 4y equals 8, and going through 2, 4. So I need to solve this first. I get 4y equals negative 2x plus 8. Divide by 4, y equals negative 1/2 x plus 2. So right here, I have a slope of negative 1/2, and I want this equation to have the same slope. So y minus 4 equals the same slope, negative 1/2, x minus 2. Gives me y minus 4 equals negative 1/2 x plus 1. So y equals negative 1/2 x plus 5. Let's switch our color real quick. We want something that's perpendicular. So perpendicular is going to mean that we're going to have an opposite reciprocal slope. And I spelled reciprocal wrong. We need to find the slope of this. We get y equals 3x plus 4. Our slope here is 3, which means the slope that's going to be perpendicular is negative 1/3. So we're going to be using negative 1/3. And then we do y minus 5 equals negative 1/3 x plus 1. So we'll have y minus 5 equals negative 1/3 x minus 1/3. And we add the 5. Negative 1/3 plus 5. All right, so we're gonna like add some fractions. Again, not a big deal, it's fine. It's 5 over 1. Need a common denominator, so multiply by 3. So this is like negative 1/3 plus 15 thirds, which is 14 thirds. Nothing to panic about. We get y equals negative 1/3 x plus 14 thirds. All right, and then last, we want something that's parallel. So we want the same slope. And it's parallel to 6x minus 2y equals 11. I got to solve this first. So negative 2y equals negative 6x plus 11. Divide by negative 2. Y equals 3x minus, I don't know, 11 halves. We don't really care what this is. Honestly, if I did that wrong, it wouldn't matter because all I needed from this was the slope. So our slope is going to be same slope, 3. So we'll have y plus 4 equals 3 times x plus 6. We get y plus 4 equals 3x plus 18. So y equals 3x plus 14. All right, there you go. You have all your examples. If you want, you can get started on some of the problems from the book. Otherwise, like if you have questions from these, make sure that you come in, bring those questions, as well as any questions that you have from the notes.